The first company presenting will be SOVNA. Guy Shahar, the CEO, is going to help us out.
Good evening. I thank Jean Dolgin here in Israel and Jonathan Shapira back in freezing Boston for the opportunity to present here. Actually, it's a special day for us. Besides presenting here, today we just completed the first installation in Israel, and we have a working site here in Tel Aviv. I thought it's going to be the picture that I sent you, Jean, a few hours ago. Later in the presentation, I will show you a picture of the working site in Tel Aviv. So let's talk about what we are doing. Wind power is a huge, amazing business. You have wind sites, wind farms installed in every place with good, sufficient wind, or at least plans for have one. There is one clear place with strong wind without turbines, and this is high-rise roofs. Looking on the high-rise industry, you can see that building owners and developers are looking for new ways to increase value, either by branding or by new income sources. On the other hand, in addition, there is new regulation and new policies that encourage distributed energy production, especially solutions that can address the peak demand problem. Looking on the potential market for urban wind, we are looking on a $50 billion market, and I'm not mentioning new construction. So what are the current solutions in order to address these potential markets? Current solutions are focusing on the single turbine performance. They fail to address, or they do not deal with where you locate the turbines, and they do not deal with the connection, with the problems when connecting multiple wind turbines. In addition, the problems and the challenges when integrating into high rises is something that current solutions do not deal with. So what we are doing, actually, it's fairly simple. We integrate vertical small wind turbines on the edge of the roof of high-rise buildings. This is the urban wind farm. We connect the turbines into one array. If this is the building, the turbines will stand on the top, on the edge of the roof. There are 3 points to bear in mind. In new construction, when the building is still under design phase, the turbines can replace the designed screen wall on roof level, and then the ROI on the system is getting down to 1 year. The second point is, when integrating into existing construction, there is no need to retrofit the structure system of the building. And last, we are not turbines manufacturer. SOVNA brings the technology and the industry know-how in order to integrate the turbines array and connect them to the grid. Let's look on the system for a minute. We introduce the multi-input inverter system. Our unit collects the power from multiple turbines and reduces installation and maintenance costs. In addition, it increases efficiency. When SOVNA will be operating multiple wind sites, our control unit will enable us to remotely monitor and control all turbines, and will give us the ability to improve or to have all turbines working on their best point, in the best efficiency. One additional point, looking on peak demand. Our central unit will soon have the ability to store the energy and release it upon demand, on peak demand. Our solution, or the advantage of our solution, is that due to the relatively small scale of energy produced on the roof, we can store it on the roof in low cost. It's going to be cheap, it's going to be green, and it will enable SOVNA, it will release SOVNA from the dependency on the supportive feed-in tariff and will allow us to receive for each kilowatt hour produced on the roof the exceptionally high feed-in tariff of peak demand, the peak time tariff. Let's talk about the wind. At the end of the day, we harvest the wind. SOVNA understands that locating the turbines in the right place sometimes is much more important than the efficiency or different kind of developments that make the single turbine more efficient. But although the wind on the high-rise roof is very strong, it's hard to predict the specific wind pattern on the roof. Sometimes on the same roof, even few meters apart, you have double wind speed and no speed at all. We've developed a computerized model that enables us to determine the optimal location of the turbines on the roof. It calculates measurements from existing wind data together with the given roof plan, and the output of this model is the exact location of where we should install the turbines. In addition, surprisingly or not, most of the wind hitting the turbines is not the horizontal wind on the roof level, but the sum of the wind hitting the building through its height. We've developed an element that enables us to control and direct this vertical wind into the turbines, and this ability will improve efficiency and improve production. Thank you. Now, I'm sure that those slides are interesting enough. I mean, wind and roofs and real estate are always interesting. The question, is it an interesting business? So let's look on a typical project in order to address this question. A typical project in the USA will incorporate 50 turbines, 1 kilowatt installed each. Using our computerized model, we'll identify a potential roof and approach the building owner. The building owner, the guy over there, receives an opportunity, receives a proposal he just cannot refuse to. He doesn't have to put any investment up front. He receives great PR and lease for his roof for 20 years. So who is financing if not the building owner? SOVNA will joint venture with a financial investor. They will finance the project and receive all income from electricity and benefits for the first years. SOVNA will design the site and integrate the turbines using our technology and our industry know-how. And a local installer, of course. In each place, we'll have our installer in order to integrate the system. The price of this typical project is $500,000. The ROI on the system is 5 years, and a typical project life is 20 years. Let's see how we benefit from this ecosystem. On each new installation, SOVNA will have 20% of gross profit. In addition, in the first years, while our financial partner or the investor receives all revenues from electricity, we will have a modest but steady income from O&M, from operation and maintenance process. The minute the site comes back into our ownership, we're going to have revenues from the electricity. Now think about multiple sites, even hundreds, on the city roofs. Each one produces energy, and we hope that each kilowatt hour would go only in the peak demand, and you can understand the scale and the opportunity in what we are doing. We are talking about a long value chain when coming to develop an urban wind farm. Our team brings various different skills required to address that value chain. Erazela is an architect who was designing some of the major important projects, high-rise projects in the world in the last years. Kobe Kucher is a scientist. He's specialist in urban climate and CFD models. Okay, this is us just yesterday afternoon on the top of a high-rise in Tel Aviv. Today, as I said, Jen, the turbines are already fully installed and ready to run. And it's a great, great moment for us. Until now, we are self-funded. We are looking now for $1.2 million, and the majority of the budget is going to be directed to implement 2 full-scale sites in Tel Aviv and in North America. We see this urban market, this urban wind market, as a new emerging market, and SOVNA is going to be a major player. Thank you. Sorry. Any question in Boston, Jonathan? Yes, please. In a cheap and easy method, which I will be happy to speak about with you. Any question? Yes, please. Probably in NYC, New York. Broadway and Uptown. Really? 91st West and Broadway. Okay, thank you.